Okay, so this is our last day of review for the stretching and shrinking test, which has lots of graphing on it. So your best friend in graphing is the XY chart. I would have started in my ideal world with the parent function for this, and over 2 and up 4, and I'd know it's a parabola, and it's been moved, hasn't been moved at all. It's been, what's that 2? Stretched. Is that a vertical or horizontal stretch? Vertical stretch. Okay, so then I take, if it's vertical, I take its heights and I double them. See, 2 being doubled. So I take its height here of 1, I double it. Height 1, double it. Height on this one is 4, sorry. Over 2 and up 4. That dot's off a little bit. I apologize. My alignment's off, so it's everything's off a smidge unless I'm really careful. Okay, so this has a height of 4, and I need to double it. So now I'll have a height of 8. And now my new, I should get one more like that one. And red point again. It's so hard to stay accurate trying. Becomes 4, and then this 4 becomes 8. There we go. I connect those green dots. And that being not changed, I connect these green dots, and it's just on the inside of the original points. Even though we didn't squish it left-right, it kind of looks like that. It has the same kind of effect. So every point, though, if you look at it, has been gone twice as high as it was. And this point went twice as high as it used to be. Okay. Now, what could you have done to check yourself? XY chart. And you just check a few points, like if I stick in 0, what do I get? I stick a 0 in there. 0 squared is 0 times 2 is 0. And I stick in a 1. A 1 goes in here. 1 squared is 1. 1 times 2 is 2. 1 comma 2. Over 1 up 2. See, it's matching up with my green graph, so yes, I did it right. All right, now let's talk about a different kind. What about the much more complex kind? Like, everybody, please scroll down. Why don't you pick one for me that you would like to see help with? I think it's scary looking.
Let's do 5.
Okay. Got a request for number 5. All right, it's got that fraction in. Do you remember that this is the butterfly one? Its parent is 1 over x. So do you remember what the 1 over x looks like? There's only 2 key points. They're that, and then it gets closer and closer to the axes and never touches them. That's the original butterfly. Then what you got to do? What's this plus 2 right there mean? Say it if you know it. Right 2. How about this one right here? Up 3. So right 2 and up 3. Ah, it is on the inside. Look at the 3's on the outside. If the 3's on the outside, can you tell the other one must be on the inside? Now, I know you think it, but there's no parentheses. But I've told you, on big fractions, you have parentheses here whether you see them or not. Remember that? That makes it on the inside. Okay, so that's on the inside, and it's right 2. And then the other one is up 3. Right 2. A minute, there we go. There's 2 to the right, and where was I here? There we go. 2 to the right, and then up 3. Up 1, 2, 3. Up 1, 2, 3. And then I just need to figure out where those lines are, those asymptote lines, and they are running right here and running right there. And I get closer and closer to them and never touch them. So there is my moved graph. Would it be smart to check myself if it was a test? Oh yes, X and Y. Now let's be smart about the numbers we pick here. Do you get you don't want to put in a 2 because you'll get 2 minus 2 is 1 over 0, which doesn't exist. Okay, so putting in a 2 wouldn't be very smart. Okay, that phone goes on my desk. That phone in your hand. Oh, that's not a phone. It's a calculator. I apologize. Man, it looks just like a phone. I thought you were texting away over there, right out in the open. Okay, pink Calculators are kind of rare nowadays. All right. So anyway, I'm going to stick in like a 3. I put in a 3 right there. I want everybody to figure out what comes out. I need you to be good at this. When you put in a 3, what comes out? And you'll be able to know that the answer is, make a chart like this on the side of your paper. And then I want you to compare it with the kid next to you. We're putting in a 3 into the function. Don't say it. Write it on your little chart. Yes, sir. Yes, you do need the asymptote lines drawn in there, and I will remind you of that on the day of the test, too. It's the only function that has an extra, like, supporting cast besides just the actual graph itself. You do need the asymptotes drawn in there. And again, I will remind you on the day of the test to put asymptotes in on that kind of function. It's the only function that has them. Yes, ma'am. All right, well, one thing that you can do is start with the parent function as I showed you, and then move everything, including the asymptote lines, in this case, 2 to the right and up 3. So I move my asymptote lines 2 to the right and up 3, just like I moved the function 2 to the right and up 3. The other way to do it is to just move your graph, and then when you have got your graph moved, you'll be able to tell where to draw the lines, because there's a gap. See this gap in here? You know that you should draw the line across there. And there's a gap this way. It's a little harder to see, but and then you know you'll be able to draw your asymptote line in there. Okay, did you put in the 3 and get 1 over 1, which is 1, plus 3 makes 4. 3 comma 4. Raise your hand if you had that right. Okay, good. All right. Now, some of these will turn out to be decimals. Like, let's say I put in a 3 in there. Or no, 4. Sorry, I just did a 3. Say I put a 4 in there. So then I have 1 over 4 minus 2 is 2. 1/2 plus 3 is 3.5. It's not like it's impossible to graph 3.5. I go over 4 and up 3.5. So that would be like right here. The other point was right here. And if you just keep graphing enough points, you'll be able to tell, oh, it's getting shorter and shorter, but it's getting really, really close to this dotted line here. All right. Okay, so next kind that we want to talk about briefly here is, everybody look at problem 8. What's different about problem 8? It's got the F word in it. It's got this little F, scripty F in the function. It's saying, I don't know what the function is. I don't know what F is going on. Anyway, so what function is it? It's the squared function. So then you have to go exactly where that is. Exactly where F, by the way, F goes with these brackets. This F and these two brackets all go together. Where that is where the squared is. Okay, so this is, I'm just recopying it over here, 1/2, and then it says F, but I know what F is. I know it's squared. So I put right where it had its parentheses, I know to put the squared function. If this had been absolute value, I'd be putting absolute values right there. But it's not, so I won't. It's the squared function. So right where these parentheses were, I put a parentheses and I say squared. And then what still has to go in the parentheses? 1/3 x. Now, this is a pain in the butt. This is a tough one. Choose XY points wisely is my advice on this. Because if you try to draw the original parabola and all of its parent points, you can do this. It would work. But man, you're very likely to make one dumb mistake. Like, let's say you forget that means 3 times wider, and you're thinking that means 1/3 is wide. You see how right there you'd be done? If you use an XY chart, you won't make that mistake. What I think you should do is get a ballpark idea of the function first to know which points to pick. So do you agree it's generally like this? Do you agree it's generally half as tall? So it's kind of got shorter here. So it's kind of like that. That's that half as tall thing. And the last thing I'm doing is this, which is not 3 times as wide. No, wait. Not 1/3 as wide. It's 3 times as wide. So this thing got really wide. So do you get how it generally should look like that really wide parabola? So now that I know that, I can pick x's that are kind of anywhere, you know. Might as well start with simple stuff like 0. So now, let's put that into our function. Put a 0. And what do you get? It's all multiplied. 0. Let's try putting in some strategic numbers here. Like, do you really want to put in a 1 here and have to take 1/3 squared? That's kind of a pain. So 3. 3 is a good one. Put in a 3, because 1/3 of 3, 1/3 of 3 is 1, and 1 squared is 1, and 1 times 1/2 is 1/2. 3 comma 1/2. 6 is a good choice. Stick in a 6 right here, and a 6 on my chart. 6, half of, no, 1/3 of 6 is 2. 2 squared is, say it. 2 squared is 4, and then 1/2 of the 4 is 2. There we go. So 6 comma 2 is on my graph. So you can tell how stretched out this parabola is if it goes through these 2 points. We know it's kind of going like this, right? So this one's really stretched, really wide. All right. A little bit more help on your review worksheet. Hold on. Stop that. Clear the ink. Okay. There's a lot of those ones with F in there. What's saying is, here's directions on what to do to this. It's saying, I think you should do an outside reflection, which is vertical on the outside, right? So that's a vertical reflect. And it's saying, I think you should move left 1. Do you remember the order you're supposed to do it in? What's supposed to be first? Inside. I recommend you do it inside first. Okay. So let's say this one. I'm going to call it M, R, and Q. What should be first? R. What should be second? M. And then Q is obviously last. Would you write this in order? And not just say R. Say, first you should do a vertical reflection, or whatever it is. Okay, use the official words, because I want to catch and see if some of you guys have forgotten to use horizontal and vertical and stretch and shrink appropriately. Okay, you should have started on the inside. You should have said right 2. Number 2, you should have moved to the outside and should have done this, and you should have said, is that a vertical or horizontal? Vertical reflects. And the last one is the outside one, which is that one, which is down 3. Good. Let's do one more like that, except here's a function that's a little more complicated. Y equals negative 2x plus 4 squared. What should be first? What should be second? What should be third? Okay, first was inside, which is left 4. Now, if you were working with a kid that does not have me as their teacher, they might do this in a different order. It's true, you can, if you want to, do it in a different order, but be careful. I've told you a way that will always work. If you start on the inside, and then you move to the outside, that's a way that will always work. If you don't start on the inside, I can't promise you that you will get it right, because there's ways you can do it wrong if you do it that way. So again, they're not wrong if a friend tells you, but you can start on the outside. It is true, but I've taught you a way that will always work. All right, then you move to the outside, and have I told you to stretch before you flip? Do you remember that advice from also works in gymnastics? Okay, but this, since they're basically the same thing, you get the negative 2 is all one thing, really? You could do it in either order. Does not matter. So if you did the stretch, vertical, stretch, factor 2, then that was good. If you instead did the other thing first, vertical, reflect, that was good too. I don't recommend you say over the what axis, because if you screw that up, I have to mark it wrong. And I know vertical's this way, but a lot of times kids get that confused with the y-axis and so they say it's over the y-axis. What am I jumping over here? That's the x-axis. So if you say the wrong axis, you'll get it wrong. You might as well just stick with vertical and horizontal. Yes? Yep. Like I said, you can do either one of these two first. I don't care. Their height by 2. Yes. Mm-hmm. Yep, you can do it. You can do that in either order. I just think it's easier to take a graph that you're already used to, and I think it's easier to stretch it first, because once you've flipped it upside down, it already feels a little weird to you. And then stretching it further, you might mess it up if you have to flip it first and then stretch it. I just think it's easier to take a graph you're used to, do the stretch on it so that it ends up with something like this. Then flipping's really easy. Just do that last. And that's always easy to do no matter what. But the order of those two, either of these two can be first. Does not matter. Okay. I think that's enough review for today. And your assignment, I strongly recommend that you do it and check it with the answer keys that is posted. All right. And that's all I have for you for review for today.